Hello everyone, welcome back. So today we are going to solve one new problem. Its name is generate parentheses and it's on lead code. It's a 22nd number. So the question is, given n pairs of parentheses, write a function to generate valid combination of parentheses. So again, last time we discussed when there is an input which is mostly a number or maybe smaller than the answer, the required answer, it's a good application of a recursion, because you need to generate something and from you can do from iteration, but most of the time recursion is more powerful and sometimes you can't do by using iteration. So in this case basically they are saying we will give you a one number, which means that is pair of parentheses. So for example, in this example they are saying n is equal to 3. So what basically they are saying, in case of n is equal to 3, they are saying you have 3 so for the terminology there are different terminologies you can use. Sometimes we use open parentheses, close parentheses. Sometimes I use the left or right. So for me I'm more comfortable with the left and right, and they give us 3 right side parentheses, or maybe open and close is better. Okay, so open parentheses and 3 close parentheses, and they are saying you need to make a combination of by using these and make a valid generate the valid combination. So as we know what is valid, in valid the valid case means when you will create a new combination that always have equal close and open parentheses. So for example, if I have 3, so this is a valid. Why? Okay, first I open one, second, third, then third, second, first. So it means it's equal. It open, this one is kind of a cancelling. Okay, this one can do this cancel, this one can do this cancel. It's a valid. Okay, then I started this. So 1, 2, and so here I use 3 open and 3 close, which is good. But for this the closed one, there is no more open pair. So I can't cancel this one and I can't cancel this one. So it's a wrong, it's not a valid combination. So valid combination means you always have a equal open and equal close. Like they can be a pair and they can cancel each other, and in the end you have a value which is 0. So again coming back to this, basically they give us n, which may be 2, maybe 10. So first thing, what does that mean, 2 or 10? It means you have 10 open parentheses and 10 close parentheses. Okay, and once the data is there, you need to take and you need to make a combination. But now the problem is we need to think from the computer perspective. So machine perspective, machine in this case machine is dumb. I need to write the instructions and machine is only executing my commands, nothing more than that. So once these type of question comes in front of you, from our perspective we can manage easily. Okay, so if there are 3, I will make like this, and I'm doing a lot of stuff in my brain. But once I'm going to put this into the form of the instructions to the machine, things are pretty complex, and sometimes you are not able to complete, you are not able to make an algorithm, which is okay, it happened always. So we need to do this. So we need to figure it out, are we able to make the tree? If somehow we can figure it out, I can generate this by using tree. It's pretty easy, because we discussed last time, once you have a tree, algorithm is very easy to write. So what we can do, first we can play with this one. Maybe 3 is pretty bigger, we can take the 2 example. So in case of a 2, they are saying you have 2 open and 2 close parentheses. So in case of a tree, I want to take a tree, what type of techniques we have which we can use to throw to the computer. So first, every time when you are playing with the code, or every time you are giving the commands to the computer, you need to go one step at a time. You can't do two steps. One step means one instruction will do one thing at a time, and you need to break down, and you need to try to understand. Your brain works differently and machines work really differently. So how we can play with this one? So if I have this and this, and if I'm doing like, okay, okay, I'm not going to machine first, I'm thinking on myself. Okay, I'm saying take one time this, okay, then take this one time. Is it a valid? Uh, but yeah, it's valid, but still we need to complete a whole combination of two. Then take this again one time, then take this again one time. Now is it a valid? Yes, valid. Save this. Okay. Then I can say now this time take the second one first. So I'm saying, okay, take the second one first. Then take this one. Then go back, take this one. Then go back, take this one. Okay, it's same, so no need. Okay. Then take both together, and from this side take both together. Okay, this one is accurate. Okay, then take this one, and then take this one, then take this one, then take this one. So this one is not accurate, it's not valid. So what I'm playing, I'm trying to figure it out what pattern I can use, because I used to write code for the recursion. I know in the form of a recursion you always send something one by one. So I'm trying to figure it out, okay, how should I send my information to the recursion so I can make something like that. So one thing is, we can see which is clear. If I start from this one, start from the closing side, it's invalid, because every time when you start from a closing side, there is no more open who can cancel that, so it's invalid. So it means I need to focus on only this part. And in this case, what will happen if I'm taking one from here and then took one from here, then one from here, then one from here, it's a valid thing. Then I'm saying, okay, take both. Both means in the form of a recursion, take first one and then take again this one. And every time also in the form of a computer, when I'm giving the instruction, what type of operations I can do. So if for example I have something already this, I can ask to the computer, okay, put something before you, put something after you. So if I take this, I need to manage also this where I need to put. For that, we can now try to make a tree first, and then we will see. By the way, I forgot, we will discuss again two pretty different methods, and the second method for the same question I will discuss in a separate video. Okay, so now in this case I'm saying we have 2 and 2. So if I have 2 and 2, also I can make this so it will be easy. And I'm saying, okay, take one first from the open side. So when I'm taking one from the open side, this will be the remaining thing. So it means I have one, this. And because it's a tree, I can make how many I want. I can make 3, 4. It totally depends upon me. But I'm going to start first. Just like we know, tree always try our best to start from the first branch, then create 2 branches and then check what is going on, then create 3 branches. So in this case, I'm saying, okay, take them from here, don't take from the left side, only take from the right side. Okay, so this is our tree. Then now the step is all same. Take one from here and take one from that side. So take again one open, and don't need to do anything with close, and we are always doing on the right side. Take always left. Left is still same. The open is still same. Take one close. So in this case, I already have one and this. Until going good, I will complete first this tree. Then in this case, I'm saying it's going to -1 kind of, because I need to take one more, and this is kind of our base case because we can't go with that. We have this limit, so I will say okay, this will end here. Okay, so it means I somehow figure it out a base case when I'm taking one by one, and if I approach where the value is left parenthesis 0, it means it's a base case, and at that time the combination is, currently my combination will be something like, looks like this, which is invalid, so I don't care about, and I need to close from the return from this. And then its right side will be, I need to take one from the close side, so this will be like this. Again it's 0, and on this side I have now 0 0. I took one more close and I found this one is accurate. So one more base case. So one base case is when both are 0, then we need to check the expression. Is it valid? It's valid, it's our answer. When if the left side, any of them, any parenthesis is 0, one of them is 0, then it means I am on a wrong path. So two base cases. Then on this side what will happen? 0 and 1. And we also decided we always put the new value on a right side of our character array or maybe string. So in this case I put here, and in this case this will be 0 and no, sorry, this will be 1, because now this time it's a right tree. I need to take from the right side. So in this case we need to put one closing. Okay, now here on the right side again it's 0, already 1 0, so cancel, return. In this case I have 0 0, because this is the closing one is remaining, so I took from this side. And in this case this will be 0 and 0, and this case is, because it's -1 now at a base, so we figure it out, this one also, this one, and so this one is, and this one is unique, and we have both zeros. And we figure it out one more condition: if left parenthesis is 0 and right is not 0, it means do return, because now we approach at a place where we can't do anything. And then the same on the right side. Okay, now we will try on this side. I'm sure all of you are already figured it out. This tree does not make sense to start, because we are already going to start from the open, one closed side, so it always invalid. But still, for this we can do little bit more, and we will optimize later. First we need to figure it out, the brute force our approach. So in this case I will say 1 and 1 is already there, and then this one, and on the other side it will be 2 and 0. So in this case it will be, because 2 close parentheses, and still I have 2 open. So in this case 1 and 1, this one is also 1 and 1, but both are different, so it's not a memorization problem, we are sure. And the second thing is, I can complete, but it takes time. So we know this one is not able to possibly be valid, and this one again the same, because we are always appending on a right side. So if I go with this structure, can we achieve what we want? It look like yes, but again, in case of a tree, I don't care about this tree first. First we need to figure it out how it's working. So there I have 2 branches, then I have 2 and 4 branches, then it's going to be 8, and then okay, there is a we can see the pattern 2 4 8 16 2 power n. So in this case we have 2 power n, no, it's not 2 power n. Okay, for time complexity we will come later, but now I need to make a full complete tree without any conditions so I can start writing code. So I'm saying what will happen if I have this, maybe I can take this space a little bit here. So we started with 2 branches, yep, then we move to the 4 branches, okay, until this, then we again move to the 8 branches, okay, then basically here, and then after that again some of them are already closed, but we don't care, we are making a complete tree first. So this is our last case, so I will say this is our complete tree. So 2 4 8 16. Okay, so how to write code for this tree only? So I'm going to write a pseudo code simply for this one. So I use black a little better. So I have some kind of a fun, and its name is maybe f, that is taking some kind of a parameter. What parameter we should send, that we will discuss later, or maybe I can say for now n, or maybe we are already aware of, I can say open and close. So I will say open and close, O and C, left or right, open and close. Then what we need to figure it out, one is a base case, how many base cases we have in this case. So I'm trying to make that tree, but I'm trying to figure it out some kind of a base case so we can complete this tree. Okay, maybe we will come back here later. I can write, okay, there should be a 1 base, nice. Then after that I need to make this, and we can see there are always 2 branches, so it means I need to call this function 2 times, 1 time, 2 time. Okay, now this is a complete function against this complete tree. There will be some kind of a base case, we will start, and if I try to trace this function, it will make the same tree. Next, we can move now towards what we really want to achieve. I want to achieve this. So how I can achieve this? First we can discuss the base case. So in our code we figure it out. Our base case is if O is equal to 0 and close not equal to 0, like this case, then do return. Okay, 1. Then there is one more base case. If, okay, I'm removing this. Okay, how to make, okay, I'm using this left and right so it will not confuse. Left and right, this one is left, this one is right. So left means left side parenthesis and right means right, close ones. Then if L is equal to 0 and R is equal to 0, then this case it means then we need to figure it out something. Okay, any other base case on the other side? I think just like we discuss. Okay, first we will go with this. This one is done, base case. Now I need to make this. So I know I need to save some information like this. How many parentheses? So for that I can send a string S, and also we need to save the answer. So I need to have some kind of a data structure. Most probably we can say, okay, in this case, if I want to make a complete tree, I can say answer will be a hash set. So it will automatically take care of the duplication. It will take only one. So this one for now is a hash set. So maybe we can call this function somewhere here for the n2. So this is our main program, and our client or our user of this code is saying, okay, I have left 2 and 2, and there will be empty string start from this, and I'm giving you the answer, which is a hash set of string. So this is our call. So until now we are in a good situation here. What's next? So there is to complete this part, we need to discuss now one more thing, the valid parenthesis. So how to figure it out, a valid parenthesis? It's pretty important. We need to write a code, and valid parenthesis. Okay, I'm going to write this fun valid, and I'm saying I will give you string function. I will give you string, and you need to return me a boolean. So how to validate if the given string has a valid combination of parentheses? And you remember there are two techniques again. You can use the most famous and the easiest one is stack, and the second one is by taking a one variable. So we will go with the stack, the easiest one. So in this case, what will happen? I have a stack, stack. I initialize this. Then I need to run a loop. And what I need to do, just like we discussed first, you need to take these parentheses, and in the end you need to figure it out. So is it valid or not? So for example, if I have a stack, I take this, I'm saying, okay, when you see the open parenthesis, put this in a stack. So this is open, I put this in stack. Again open, put in this stack. Close, when every time is closed, go and pop. Now basically loop is also complete. In the end, check if the stack is empty or not. So by doing this, if stack is empty, it means we are done. It's a valid one. We can take one more example. I have like this, for example this. So we already aware of this one is wrong. Okay, in this case it directly comes to the close one. So in close one we discussed we need to pop, but stack is empty. Currently stack is empty. So in this case, in Java and Kotlin, I'm not sure about the other languages. Most probably it will crash, because it's if you ask stack.pop, and if stack is already empty, it is going to be crashed. So what we need to do, it means I need to figure it out. If my stack is already empty and then there is a close, it means it's no. I need to return from there with false. So we need to apply the same thought here. So what I will say, okay, if ch is equal to open parenthesis, then put push ch, good, else I need to check if first else means it's coming to the close one now, and I need to figure it out if stack is not empty, then I need to pop else return false, and in the end return true. So we need to trace this first. We will see if there is anything I did wrong. So if I have this, so first ch is this, I put in a stack, okay, then next time ch is this, I put in a stack, then next time is this, come, so it's not this, come here, stack empty not o, okay, then come here, comes here, stack is empty not o, done, return true. Okay, okay, now I want to give some different input, maybe like this. In this case, what will happen? See this, push here, not empty, o, now it's empty, again come this, push, then come here, is not empty, yep, and then po, loop is done, return true. Okay, can we go one more example, only this. In this case, what will happen? Comes this, stack this, then comes this stack, then here, and remove. Now stack is not empty, remove, and then still I have this, but now loop is done, so it means this true should not be here. It look like I need to again check stack dot is empty. I need to return this. So in this case, stack is empty, no, so it will be false. Is there any other issue? Okay, if there is, you can improve this one, but I'm moving towards again on our main topic. It's a part of our topic, I'm not saying. So for now, I'm going to remove this, and maybe I can show you the other way also by using, I'm not going to use stack, I'm going to use a variable, because stack is good when you have more than one kind of input where you need to decide, like, so most of the time we have questions around this, you need to figure it out if this is a valid syntax tree. In that case, it makes sense. So you have a stack, you are pushing and then popping. But in this case, you have only one type of an input, like always this. So I can manage easily by using one variable, which may be count or anything. So I'm saying, okay, I will take this as a count. It starts from 0. So in case of a push, what we do, in case of this, we always push. Now what we will do, we will say for ch in s, if ch is equal to this, do count plus plus, same like a stack thing, but now I have only one variable, else in this case stack is not empty issue, because what will happen in this case, maximum it will go into the negative. So yeah, we can go with this negative. And then if at any point my count is less than 0, it means I am in a wrong state. Yes, so if count is less than 0, return false. Okay, so this is our loop, and in the end, same just like we did in stack, I need to do return count is equal to 0. So in this case we can again give some valid and invalid inputs. So I have first this valid input, so I will run this count is 1, this count is 2, this count is 1 because it's minus minus, and then it's not 0, less than 0, 0. So minus 1, it comes to 0, 0, loop is done, count equal to 0, cool. Then one invalid input maybe. Okay, first I can give this, so it comes, it's a minus 1, minus 1, minus 1, throw, nice. Okay, then I can say, so in this case is 1, then it come to this 0, then it come to this minus 1, and minus 1 again return false. Any complex kind of this. Okay, so in this case count is 1, count is 2, then comes this minus 1, so it now 1, loop is done, count. So yeah, this logic is also work. So I will go with this one. So easily you can determine it's a stack, then stack dot push, then stack dot pop, but you need to add an extra check. If stack is not empty, then do count, and then also I think you need to put this, and in the end it's empty node. Okay, so please remember we have this method. Now I'm going to remove because I need some space. So now we figure it out. I need to check if valid s, then I need to add this into our set and then return. Return is outside of if. So now we are around clear against our base cases. Then what's next? Now we need to design the remaining part. So I will start like 2 and 2, and there is no base case for this condition. What I need to do, I will discuss, we need to take 1 from the open side. So I will call again this function f with L minus 1, and the right, the closed one still same. Then I need to send s. What will be my s? So this time my s will be empty string, not empty, sorry, it's already empty. S plus, so in Kotlin plus means append, and I am saying okay, a character of open, and answer is always same. So this is my first call like this. Now I want to call this one f. So in this case we are not doing anything with L, we are saying we will do minus with R, and S plus, and in this case I am sending the closed one just like this. And this is, and every time when you do this, it's a new string in a memory. Yeah, we are abusing memory, that we will discuss later, but it's a new always, and this will be done. So can we try to trace this method first if it's working? I think there is one more base case we can write for the right side one, but first we will try. I want to remove this, but how then I can trace? So maybe I can try to move here fast. 2, 2, 1 2 2 1. So this side I'm not designing full this one, and take this from here. 1 2 is 0 and 2, this one is 1 and 1, and this one is like this, and then it's end, and one of this side is 0 and 1, then this side is end, this side is 0 and 0, this side is 1 and 1, so it will go to the 0 and 1, this go 1 and 0, and then this side is again cross, this side is 0 and 0, which means base case, and in this case again 0 and 0, and this side is cross. Okay, so in this case what I'm saying, okay, call this function. So I'm calling this function with 2 to empty, and I'm not putting for now answer. So this is my call. No base case, then I need to call now this first. So I'm writing f for first and second. So like we remember, okay, we call this function now, and in this case I did -1, so it will be now 1 2, and this way I'm sending this. Okay, I'm directly like writing this. It's again not a base case, again call for first. In this case 0 2, and okay, I'm also not calling this function, so otherwise it will confuse our brackets, parentheses. Okay, done. So this is again, is it a base case? Can we return from here? So we can see there is some kind of, so if L is equal to 0 and R is not equal to 0, this condition looks like, if I return from here, then what will happen? 0 2, is there any case where I need both 0? So left is 0, is 1 is a valid case, so this condition doesn't look right. It means we can go not from, okay, so basically I am returning from here, so it is -1 and 2. So this condition is, if left is less than 0 or right is less than 0, then return. So in this case, and if both are 0, so both are 0 not, so this is still not a base case, then I am calling again for the first. In this case is -1 2, and now we have this 3, because every time I'm taking s plus 1, so it's 3. Now this is a base case, return 0, so I will return from here. And basically this string is, we are always sending a new object by creating a new object. So once we are returning back, we don't care what is that. Yeah, we need this one. So I am now here. So this is same. Now from this side, I need to call the second function. So in case of a second function, what is my input? L will be same. So it's 0, right? R -1, which means 0 1, and I need to s plus. So there is s this. So I need to send this and this. Okay. Then from here, is it a base case? Any base case less than 0? No. Both are 0? No. So no base case. Again, I need to call from here first. Okay, I am moving this call from here, so we have more space. So in this case, what I send 0 1 and 2. Currently s is this, so 2 parentheses open and 1 close. So this is not a base case. It means no base case. Again, start first call, and when I will call first again here, it's going again -1 1, like this condition. And in this case, what I send, this one is my previous string plus this, but I don't care because it's -1, it's going to return. So close and return. And now I'm going to call again the second. In case of a second, I have 0, 0, 1 will move to 0, 0 and 0. And then I have s plus this. So in this case, I have this, and append this one. Now we are moving towards the base case for the here. So base case is L is 0 and R is 0. Yes, L is 0 and R is 0. Is it valid? I'm calling now valid. It's a valid parenthesis, yes, so add. So now my answer have, so for example, this is my answer array. I'm going to put my first valid. Okay, once this is done, from here return. Now I'm going back to here, and now from here second, this is function is complete. Now I need to go back from here. Again, this function from here is complete. I'll need to go back here. But in this case, then I need to call the second. So I'm removing now because these are already removed from the stack. So this one is complete. Now from here, I need to call second. In this case, now I'm here, and what is my left is 1. So there is no change for left. And what is right? 2, 1, like 2 minus 1, 1. And at this point, my input is this. I need to append this. So I need to send this. So basically now we are here. Okay. Then, is it a base case? No. Then again, I need to call from there f. First, this call. So again, I'm taking here from, so it will be easy. So first call, 1 will go to 0, 1, and append is this. Still not a base case. And if we see here, which case we are currently here. So not a base case, again call first. Now this time -1, 1. Sorry, this one is append because we need to append this. And now it's base case, so we can return. So we are back doing nothing. Then I'm calling second. In this case, 0 will be 0, 1 will be -1, s plus append. So I have this s, and this I need to append. And this is a base case, a proper one. It means it's going here. Cool. And from here now we are finished. We are back. Now I need to go from here to here. We are here. Now I need to call second of this one. So in this case, from here we are coming at, we call this from 1, 1, and we have this. So currently where we are, so we did this one. Now I moved here, and I need to go on a 1, 1. So basically now we back until this point, 1, 1, and I have this. So in case of a second, this will be 1 and 0. And what I need to append is this right side. So I did append this, and this is not a base case. Yep. Then again I need to start next call. In this case it will be 0, 0, and I need to append this value one more time. Okay, so in this case I'm going to, it's a base case, yes. Now I'm taking this value. Okay, I did small mistake here. In this case we are here 1, 0, and when I'm taking this, it's not like this. It should be like this, this, and this, and this. So is it valid? No, it's not valid because it's 1 open, one close, then one more close, so it's minus already, so we are going back. So we are not going to add answer, so it's not going to be a part of our answer. And then the second call, in case of second call, I need to 1, and this is going to be minus 1. And what I need to send now, this, and this, and minus 1 is r is less than yes, so I'm going to return from here. So return from here, then moving return from here. So now we are back to this 1 2, and this one is also complete, so I'm going to return back here. So now I need to call from second here. So this one is done, we completed this and we found these answers. Now in case of a second, I can call this time L is 2, R minus 1 is 1, and my start will be, this is a close, because I need to put 1. We already know this will be not a valid case, but for now we will complete this, and then after that we will optimize. But remember, if I am going to start this, it's not a valid in any case. It will never be a valid case for the parentheses if it start from the closing. Okay, so this one is not a base case, yes, no. I need to again call. I called 1 2 parentheses, I need to put this and this, makes sense. And then it's again not a base case, I need to call again f. In this case I will go to 0, because 1 minus 1 0, and r is still same. And what is my input? And now it will be like this and this. Oh sorry, this is this, and then I need to print one more. Okay, then what else? Again not a base case, and now I'm moving again, so it will be minus 1. So add a minus 1, it will going to return. So from here I will come back. So what I can do, I can understand if I'm going to start from here, it will never give me any solution, and in case it will give me any it's not possible I will get done, because my first string is always starting from the closing one. So in this case I think we can put in our algorithm one more base case, and we are good to go. So what will be our next base case? I think we can put, okay, if my left parentheses are greater than right, it means it's wrong, like in case of a 2 and 1. So my one more base case will be, where I should write, okay, I'm writing there, maybe here, if left is greater than right, return. So now this is our complete algorithm. I'm sure we are on page. So once we will start, we have now 3 base cases. One, okay, maybe I can try to write algorithm here more appropriately. So one condition is L is less than 0 or R is less than 0, so return. Done. Then the second case is L is greater than R, then return. Okay, then the valid case, again it's not valid until we do validation, this, and then I will go and I will check do valid. If it's valid, then add and then return, and then this one is a final algorithm. If we run only for 1, if I have 1, then what will happen? I will come 1 and 1, so it will call 1 1 empty. It will call, it's not a base case for first. In case of first I have 0 1 and I will put this, then it's not a base case. Then again I will run for first. Now it's minus 1 1, and minus 1 is going this, so it will going to return. Then I will call second. In case of a second, 0 and 0, because minus 1 and I need to append this. Then I will go to this, it's a valid, save this value, then return. Then I will run for the second here. In this case, what will happen, I have 1 and r minus 1, which is 1 0, and I'm going to send this, but it's left is greater than 0, so it's invalid, and we can return. Now we can see if I'm never going in a wrong side, is there any possibility we can remove our validation? Because I never create a invalid algorithm parentheses. So I remember we are here where we created a 1. So once we achieve this path, we check is it valid or not. But if we go again and we will see from our new base condition, is it still valid? So once we are here, 1 1 is a valid, 0 1 is a valid. Now this case is a 1 0. So 1 means left is greater than right, do return. So from here I'm saying now do return. It means I will never go until this, so I always have a valid parentheses. So it means I can remove this also. So no need to check. Make sense? I hope so it makes sense. Because in this case, anytime when my left open parentheses are less than close parentheses, it means there is something is wrong. Because we always, like in this case, I can try to write here. So 1 0 means we have this, this and this. Now I have only one open parenthesis, and we know we are always appending. So I can't do in start. I always do my algorithm will do this, and it will never be valid. So that's why we have this case, L is greater than R, return. So from here we will return. So basically in this case, I will now come at this tree, and from here it will return. So by doing this, we are able to remove our big O of n. The stack validation algorithm is independently is a big O of n every time. Okay. Then what else we can do? There are some improvements we can do more. But before that, we can discuss this algorithm first. So in this case, what will be our time complexity? So it look like if we will take as a whole, so at this point I have 2, at this point I have 4, at this point I have 8, at this point I have 16. Is it something like we can make the mathematical notation for this one? And my, in this case, n is 2. So I know this one is 2 power 1, this one is 2 power 2, 2 to the 4, this one is 2 power 3, and this one is 2 power 4. But if I say 2 power n, it's wrong. What we can say, can we divide more? So 2 power 2 power 3, 2 power and if I say 2 multiplied by 1, 2, 2 multiplied by 2, 2 multiplied by 4, and 2 multiplied by 8. So 2 1s are 2, 2 2s are 4, 2 4s are 8, 2 8s are 16. And if I move this again, this one is 2 into 2 power 1, 2 into 2 power 2, 2 into 2 power 3. And in this case, so it look like 2 into 2 power n, if I'm not wrong. So if we can try, so the total answer is for 16. So it means 2 is here, then 2 multiply by 2, which is now 4, and 2 power 4 is 16. And in the same case, if I have n is 1, so 2 power 2n, 2 power 2 1, 2 power 2 4. Okay, which makes sense. So this is not a constant, so we need to go with 2 big O of 2 power 2n. We can't take this because it's not constant in a equation, it's in a power. So as per my knowledge, if there is a constant in a power, that is a part of a big O. So this will be a big O of 2 of n from the tree. Yes, but if I'm going without big O of 2 power 2n, it will reduce. We already reduce a lot. So it's for a complete tree under the hood, if you are thinking from the CPU cycle perspective. Then what about the space? So space at one point, maximum how many trees we will have, the stack. We are also using extra memory, so there will be string. Every time we have a new string, we will append, and that will maximum will go until n multiply by 2. Like if I have n is 2, it's going to be 4. Maximum I have this string, okay, which is 2n. If I have 3, which is 3 multiplied by 2 multiplied by 3, it's 6. Okay, so this is 1. Then I also have answers array, a hash set, but that one you never know how much that can grow, because in case of a n of 3, we have 1 2 3 4 5, and in case of 4, it's going to be bigger. And what will be the space from the stack perspective? It's going to be at one point, if I go until n, so it will take, for example, 2, it will create 1, it will create 0, this, and the maximum tree at one point I can go this path until 8. So it look like the same, 2 power 2n. So here I have this one time, so maximum stack I can take this, and it's being, so once I'm here, what is my height? So this is 1, this is 2, this is 3, this is 4. So again 2n. So big O of n, kind of big O of n, but I will confirm again and I will write in a comment if there is any mistake. Okay, this one is done. Now we can discuss improvement here. We can improve, because I can see we are abusing our memory. So what we can improve, one is this hash set may be only a list, array list, because there is no more duplication. So it will be array list. Can I save my this object? So every time I'm creating a new object and I'm retaining the last object, because it's a recursion. So garbage collector is not allowed to take this memory back, because until my tree is out of stack, like it's popped from the memory, and every time I'm creating a new. So if we want to improve this from the space perspective, one thing we can improve this. what we can do, we can say, okay, this is our not a string, this is our string builder, and we can take care of on our own. So in that case, what will happen, maybe I'll somehow, if I'm not able to figure it out all the edge cases, sorry for that, but I'm going to give you a one more picture of this. Okay, so from now this S is not this, it's a string builder. Okay, so now we need to figure it out how we can go with the string builder. First thing, once string builder is here, I need to append S dot append, and I can append now as a character. So this is, I'm sure, we need to do. So now I'm sending S here. Then again I need to append here also, S dot append, this time this. So now, so this one is done. What else? But once we are going, we need to append. But once we are coming back, we need to delete also. Otherwise, we have wrong. So in that case, how many places we need to delete? We can try. So for example, I'm going to make my string builder. So this is my string builder. I have first tree this. Then I put the second, yes. Then I put the third, because we are always putting first, third. Now I'm moving inside. Now I'm going here. In this case, this is the base case, and it's saying L is less than 0. Yes, now L is basically -1. So I need to return, but before return, what you should do, you need to delete character add. It depends on language to language. In Kotlin it's delete character add, and which character, the last one. So, and then return. Make sense? So from here, when I'm going to return, I need to delete. So I am in a good shape. I will be here, then I'm calling this. So I will append this. Then again, I'm going on this side. So in this case, again, it will put this and it's going to be -1. So delete this. Nice. Then coming back here, then going on this side, this condition, put this, I put this. Then I'm going into this answer dot add s. I added this answer, good to go. But now I need to return. So once I'm returning, I'm here. What I need to do now, once I'm coming back here, I need to remove the last one. So in that case, I can call also delete here. And this one also is not s, is s.toString. Because now we have a same reference. So if I put s here and then again I do delete, this originally s is going to change. In this case, I'm saying, okay, it's not a shallow, it's a deep copy. Take a new string and put here, and my original string will do the delete. Again, same like that. So once I am here, I remove this and return. So I'm back here. Then this is the right place. Now I need to go back at this place. So I need to remove this. So it means I need to delete after from here also. Delete character add. Okay. Then once I will delete this, so I will remove this now. We are here. Okay. Then from here where I'm going back, and so this one is done. Now I'm going one more back at 1 2. So from here, once I'm going back, I need to remove one more. So in this case, once I'm here, this one remove this. Now I'm here, and the right of this one is going to remove one more. So this one is delete one. Done. And now I'm moving again on this side. So append one. Then I'm moving on this side, append. Then again it's going to be -1. So -1 means again go back, return here, then going back on this side. Done, completed. Remove one, then here, then going back here. This one will delete one more. Then I'm going on the right side. So once I'm going on the right side, in this case I'm here. Now I should append this. Now I'm calling this function. It means I need to append one more here. I already did append. Now I have 1 0 and I'm here. 1 is greater than 0. It means I need to return. Once I'm doing return from here, should I delete 1? If I delete from here 1, then if I delete this from here, then the case is once I'm back here, I'm going to delete. So I think we need to call also delete here. So it will delete. Then we are going back. So from here, once we are going back, it will remove this. And then once I'm going back to first call here from this, so it's going to remove again. And now I'm starting from this. In this case, what will happen? I'm now here. Let's call this. I'm here. L is greater than R. Yes. Then delete this first. I did delete and delete this and then return. I will be here and oh, it is going to be crash because now I have empty string, empty builder, and it's saying. So I think I need to put one check here. S dot is not empty. You can put this or length of a substring, then dot delete character at s dot length -1. So this is, I think we can improve this also, like this check. Maybe I can remove. I need to spend more time, but this one is 100% sure. This should work. Then what's next? Now there is one more issue. What we achieved, basically now we are not making more objects in a memory. We always have a one string builder and we are playing with that. Only that the most important point is delete character add. So it's a string builder and it's a CPU extensive operation. I checked this implementation in Kotlin. So basically it's same like just how we implemented array in my other videos. So what this will do, this will do a new copy and remove the last character. So it's always big of an operation under the hood. So it's not a good approach. Then can we improve this also from the CPU perspective, because now memory is good, but now my CPU extensive. So in that case, as we know this, the boundary of this, it's not like it's going to be infinite. I always know there is a boundary. So I think we can go with the character array. So I will say, okay, 2 multiplied by 2. So always create a character array. So now I have a character array, and by taking care of the string builder, I can take care of the index, and I can say, okay, my index. So in this case, I always send in a function like function L or my array and index and answer. In this case, how I need to take care of my index my index is always helping me to update the array, and we can say this is a character array which I initialize with maybe 0 all the characters, and every time when I will start, I will put my value at that index. So for example, in this case, I will say, okay, index 0, put this. Okay, so this is index 0, then go to the index 1, then go to the index 2, and then once I'm coming back, same technique I can use, but at this time what will be the benefit? Yeah, in the end here I need to call maybe array.toList function, which will make this array into the list of string list. But the benefit of that, we are not doing this, and we are using this a lot. If you see, we are using on 3 places. Now I will start playing with the index position. So in that case I have this big O of 1, because it's always n multiplied by 2, or maybe we can say 2n, but it's pretty better than this. Now we have a kind of a trade-off between space and time. Here what I achieved by going this, I took extra space, which is again looks like the same in a string builder. I'm also taking the extra space and I always growing. So I think that is better approach if you go with this, but no need to start from this approach. It may create a lot of issues. It's pretty difficult to tackle the edge cases in these type of circumstances where you have using index. Then you need to focus more. So we can now summarize. I took a lot of time, but it's kind of a pretty hard problem if you don't understand. So in a summary, you will come, you have a question, you need to make a tree. Try to design a tree. Once the tree is there, all the problems are solved. Now you have a tree which have different type of like different branches. Then you can think about, okay, I need to create a complete tree for the same one. Like, so in our case we always have 2 branches, so I figure it out. Okay, first create a complete tree and then create the code for that. We created that. Then I try to jump in, okay, figure it out the base cases. How many base cases? So there are 3 base cases. I wrote that. Then after that, I don't care about the CPU, I don't care about the space. I'm sending new objects of strings. And then I also created a validation stack algorithm. And once I'm sure, okay, now this is done, I moved back and I start optimizing this algorithm. And how we did, okay, maybe first we removed our stack algorithm, and then second, the biggest one win is also this one, because by common sense told me if the left is greater than the right parenthesis, like open have more than close, it means that will never be a valid. By doing that, we throw out more than half tree branches. Then we created a string builder, so there is no need to make more and more memory in a so string builder, I'm sure, is going to use less memory in compared to creating new string object, but still it's taking a lot of memory. And then later we decided, okay, maybe we can go with the array, the fixed memory, and play with the position, so we can save our this. And in the end, the last thing is, every time when you are going to make a list or a substring or anything where you can give a capacity, try your best to put that capacity, because otherwise under the hood maybe that will increase your insertion to big O of 1. You can watch my other video on how to implement the array list. So in this case, I'm always know my string builder will never go more than n multiplied by 2. And for the contingency, I'm also saying, okay, plus 2 or maybe plus 4. It depends. Like, so in this case, if I have 2, it means it's going to be 4. 4 plus 4, 8. So when this will be initialized, I have 8 bytes or 8 bytes in memory. If I have, for example, n is equal to 10, 10 multiplied by 2, 20 plus 24. So it will be, in the start, it will be 24 in memory. Now, for example, current implementation in a JTK or in your language, string builder is by default by 16. So in that case, if you give 16 and you say insert now the next one, which is on a 17, it's not a big O of 1 operation. It will take that, it will copy into the new memory, which will maybe the 32 now, and then it will do. But if I'm already aware of what will be my maximum capacity, by putting that, I can save CPU cycles. I know it has nothing with the big of when you are talking with the interviewer, but when you are writing code, it's pretty important. Save your CPU cycles, that has a lot of impact. Okay, thank you for listening. See you in the next video. Bye.